Application of Pascal law. This is a very basic example. We'll be using this bottle jack. These bottle jacks are usually rated at 20 tons, which is about 20,000 kilograms or 44,000 pounds, which is pretty large load that you can lift using this bottle jack, and it costs only $50 max. They will ship it to your house under $50. So in this type of problems, either you'll be given data, the amount of load this bottle jack is handling. Right here in this scenario is saying that it's gonna lift 4,000 pounds, and how much force you have to apply using your hand. That's what this question is asking. It could be the other way too. It may give you the amount of force coming from the hand, and then how much that is going to translate to the lifting whatever object you are lifting. So in this scenario, for example, so the 4,000 pounds coming on right here on the piston of the bottle jack, so the fluid right here will have pressure, which is the first question asking what's the pressure developed here. So you can simply do force by area. 4,000 pounds divided by area is pi by 4. The last piston area diameter is given 2.5 inch whole square. So then this pressure we get, I calculated that 814.87 psi, and the same pressure based according to Pascal law will actually go translate into this smaller piston. So this pressure will be both in the smaller piston and the large piston. Ignore the elevation. The pressure due to elevation I calculate is only about 0.15 psi. Let's say, for example, 5 inch of elevation different, really negligible amount. So this is the force going into this small piston. Then the next question is asking, so both of them are basically the answer same, because based on Pascal law, pressure will be same everywhere. The next question is asking calculate the force that is going to translate into this a small cylinder piston. Simply force is equal to pressure, which is 814.87 psi, pound per square inch, times the area of the small piston, which is pi by 4. The small piston diameter is 3 inch square. So then the total force I calculated was 57 pound only, 57.6 pound. So that is going to the small piston. That force is actually going right here, going like this in the upward direction, and this is asking how much is on the hand force. Calculate the force on the hand. And if this is a lever, all cylinders typically use some kind of lever. So this is the fulcrum or the pivot point. So if you take moments with respect to the pivot point for this force, the 57.6 pounds coming from the translated from this 4,000 pound into this small cylinder will do a counterclockwise moment, which is positive. So if we take moments with respect to the fulcrum or pivot point, and counterclockwise positive, all moments sum to 0. So then for the small piston force, which will create a counterclockwise moment, 57.6 pound times the distance, which is 1 inch, and then this will be a positive moment, and the hand force will press down, will create a clockwise moment with respect to this point. So that's going to be minus, clockwise moment is minus, and the force from the hand force and then the distance of that force is 1 inch plus 16 inch, total 17 inch, and everything summed to 0. Everything is static. When you solve fluid power problem, you assume it's static unless it says it's moving. So the total force I calculated only 3.388 pound. So to lift 4,000 pounds, can you see how small that force you have to apply using your hands? I did calculation using, perform calculation using the highest capacity 20 tons of the load lifting scenario. In that case, I found that, so instead of 4,000, if you use that 44,000 pounds, I have found in that case you only have to apply 37.27 pounds. So for the highest capacity of this cylinder, to lift 44,000 pounds or 20,000 kilograms, 20 tons, you only have to apply 37 pound force using your hand.